In today's tutorial, we are going to wrap up our process of creating a scene in the ESPN aesthetic. We will cover how to build a solver, create additional elements like circles and crosses, distribute them across the scenes, and finalize our materials. Let's dive in. First, let's create a solver to smooth our animation. Right now, if you look at the movement in the real time, the points move very abruptly as they form the letter contours. This creates a stepped look that feels jerky and unpolished during the rendering. So we don't want it, and let's try to fix this type of animation. To solve it, we need to use a point data from both the previous and the current frames. By interpolating between these frames, we can achieve a much smoother transition. Inside our solver that we have created, let's add an attribute wrangle. In the first input, insert data from the previous frame, and in the second input, current input data. In the code, we will define a target position and a target mask. It's important to remember that inside a solver, many variables need to be recalculated because the solver works with attributes as they enter at the first frame and then iterates. So we have defined the target position as a point attribute from the first input position, defined by the PT number. Also, the target mask that we get from the points from the first input, and then the float attribute stiffness that will be a channel float, vector force that is calculated from the target position minus position and multiply by the stiffness. Next, let's define the previous mask that equals the mask logo. This variable necessary because the solver recalculates it inside and we need to work with it again. Also, let's add the damping as another channel float and calculate the new velocity of the points that equals the previous velocity plus force multiplied by the damping. And let's update the mask logo with linear interpolation from the mask logo from the previous frame and from current frame with a blend variable that we have defined previously. I'm using the shortened form of writing the code like plus equals, but this type of writing the code equals that the new position equals the previous position plus velocity. So it makes the code more readable in the future and helps to understand it if you know the logic of it. Some quick tip. Always remember to cache your solver after the calculation is done. After we have finished writing our solver, we have achieved the new smooth type of animation. You may think of it like a Cinema 4D's delay effector that creates this smooth animation. So, after finishing this phase, let's proceed with creating an upwards and downwards extrusions for the background platforms. We will use a similar method to how we build the letters, but our geometry will be simple cubes scattered across the plane. Create a grid with the size of the surface that we want, and scatter node with a total count of points about 20 or 35 in my case, but you may increase or decrease the amount of platforms you want to extrude. And then let's add a box node to bound the edges of our logo. We want to avoid any intersections between the platforms that we are creating and the logo that we have already created. To do this, I have created a group that includes only the points that are not inside the bound area. Then I have added a randomization with attribute noise to change the variation of the scale of our platforms. And the same randomization for the position to place not so evenly our cubes. That will make the image more interesting visually. After, let's create a copy to points node and convert the cubes into a VDB volumes so they can interact with the rest of our scene. I have split the cubes into two groups using a group expression and a split node. This allows us to have some platforms extruding up and others down, giving us more creative control. After we have achieved our extrusion effect in both directions, we need to adjust our vex code, because right now the new vex attribute wrangles override the mask logo attribute. So let's replace the mask logo attribute to mask up and mask down to use them later on the render phase. But by assigning specific attributes that we have just created, mask up and mask down, we need to refine them inside the solver. So we ensure that materials more perfectly in sync with the geometry. So let's define a new variables inside our solver and call them new mask up and new mask down. Take these attributes also from the points, the same way we have done it previously, and use the linear interpolation in the very end to recalculate them inside the solver. After all code changes you have implemented, check it in the viewport to be sure that everything is working perfectly and your attribute is recalculating after the solver. In your main material, simply use a point attribute node as a mask in your color layer to color these platforms separately. Another common technique in Houdini that I'm using is separating the setup, where I'm creating and building all my geometry, and the render node. So let's create another node with geometry and using an object merge inside of it and put our geometry from the null inside this object merge. So this technique allows us to render in the viewport our node with our setup and be sure that everything will be in the scene, while in the setup itself we may change the flag we are using in the viewport right now. Now let's switch to creating a small spheres and crosses. Let's add the time shift node to fix the points in place after the animation finished. I'm using the frame 250 to be sure that the animation has been finished and everything stands still. After that, let's add the blast and delete node to remove any points that are not on the flat ground plane and get rid of the unnecessary edges. To do this, in the blast node, put inside the group field a little expression like position on the y-axis equals 0, and don't put the space between the symbols because it's a mistake. And after that, we achieve the points, we select and create the geometry only that are on the flat surface. After that, let's use group expression node one more time with the run function to select a random subset of points for our objects. Again, I'm using a box node to create a bounding area that I don't want our points to be. So it will help us to create a points and like crosses and circles only in the area that is not on our logo. The cloner logic in Houdini, unlike the Cinema 4D, is more complex, and it's not just drop objects into the cloner. In Houdini, we set this up manually. We will use an index attribute, a switch node, and a for each point loop. By using a spare input on the switch node pointing to the for each begin, we can alternate different objects across our points. I recommend you to carefully follow the tutorial to understand what is happening while we have creating the cloner effect here, because it's not an obvious technique. So in randomization, index randomization, put a max value with the number of your objects. For example, you're using spheres, crosses, and cubes, then it's 3 different kind of objects, and you need 3 as a max value. In the switch node, we need to add a spare input. It's not a common thing that we're doing all the time, so let's press on the cogwheel, add a spare input, and put for each begin inside this spare input. In the select input, we need to put an expression that reads point minus 1 that defines the input from which we're using attribute. This is the spare input, then 0, index, and another 0. And after that, we have created the effect of switching objects inside the copy to points process. After that, let's create another render node specifically for our separate additional elements. I'm speeding up this process because this is that we have already done. And then we may switch to the materials, lighting, and camera. And this one also will be speeded up in the tutorial because all this material we have already discussed on this channel. So if you want to dive into this more, feel free to watch another more detailed tutorials. I hope that you will find this tutorial useful for you and you have find a new knowledge and use it in your further projects. Feel free to leave any feedback, the bad one, the good one, depends on what you think. And thanks again that stays with me. I really enjoy all this creative process and love to share it with you. So, see you in the next video.